Second category. Okay, we are live. Hello. We've got some stuff to do today. Um, we're gonna start by checking on the experiments from last night. We have at least one result that it seems quite promising. I don't want to get stuck refactoring all day. I think we're gonna have some fun. We're gonna do some of like the little potential research improvements today. Some of the easy stuff. It's a Friday. See if we can bank some easy wins. And we're going to start thinking about the main experiments for next week. Jump over to Stream View. What's puffin', eh? How's it going? Okay, so this is the result from overnight. 16,700 score on 2048 in 2,400 seconds, which is 40 minutes. This is the exact same hardware that I ran the previous sweep on. We go to Constellation here. We have all of our Puffer 4 experiments, all our baselines. And you'll notice that around that same time, we only had 13,000 score before. And the best score that we'd ever obtained on 2048 is 14,300. So this is 2,400 points higher and in less time. So that seems pretty good to me. That seems pretty good. I think it would be pretty surprising, I would think, if this is not a clear-cut win. Thank you, Elliot. We're going to pull these results. We're going to look at them. Let me very quickly here. Yes. Oops. Let's just get rid of stuff that we don't need. Main test tasks for Puffer 5. Sparse maze. Hard maze, maybe. Sokoban. 2048. And Inferno. 1, 2, 3, 4, 5, depending on this one. 4 or 5 good tasks was fine. We may or may not want this one. This one honestly doesn't matter. Let's just take this off the list. Fuck this. We don't need to give ourselves one more thing to do to please academics. Welcome, Liberty. So, we have ablations to run. We've got nice 4 test environments. And we have a few easy, chill things that we can play with today. Let's start with our experimental analysis. I am going to close this. We don't mess with it. Let's just do zip-r deal 2048 logs g 2048 star. Okay. CP. Deal. Who is okay. Right. Okay. Yeah. And I believe we have our old log somewhere. Perfect. Actually, let's just move logs g dot python. Let's just look at these alone first. Okay. Ooh. Might not be super great, actually. Hmm. Let me compare something real quick, just roughly, and then we'll get it on the same axes. This is like a hard scaling result. Unless the axes are different. The axes might be different. Let me see. Okay, so we have log scale uptime, linear scale perf. So 34. Oh, hang on. Maybe this is not bad. Linear scale time. Yeah, the axes are different. Hang on, I think we're fine. So by 600, this 346 is 10K. That's one lucky point. I think we need to get these on the same axes, honestly. Any preview? Uh, so the task that we got this original result on was a super sparse maze. You have a 1 in 10 million chance, or randomly generated sparse mazes, I should say, where you have a 1 in 10 million chance of getting a reward. Any reasonable baseline that you can write will get 0 score on this. Puffer gets up to 90% solve rate. It's pretty crazy. Okay, so our best results are with curriculum here, about 0.5. With a very high prioritization coefficient. A little suspect, actually. And a high correction factor, interestingly enough. State buffer size. State buffer size appears... It appears this matters, but it caps out at the 8K. That's interesting. I think those are all the curriculum params that we care about. Let's get these onto the same axes real quick. Yeah, pretty much. Would this solve Montezuma's revenge? It might solve Montezuma's revenge. The reason I don't care about that task is because the sim is so slow. Like, we don't bother with tasks that are just super slow to simulate. And the method that this is based off of that did apply on Montezuma's Revenge, they used heuristics. Domain-specific heuristics. Okay, let's get this onto the same spot. Oh, I forgot to check the exploration decay, didn't I? Oops. Okay, it's actually quite low. Interesting. 0.8. But it does matter. This param matters. We do -1. Whoops. 1, 2, 3, 4, 5. And this goes to 25. Well, that's a very weird result. This also implies that our sweeping algorithm is messed up because these points are in the space of this. Yeah, our sweeping algorithm is messed up. So this is still a nice soda result. This piece is a very weird, though. I think we just go make some basic changes. And, we wait for protein fixes to rerun this. So this is soda up here. And this is the previous best. But then the shape of these runs is very odd. This should not be able to happen. This basically implies that the hyperparam sweep is kind of having difficulty keeping up with this number of search terms. Okay. No. We still get the result. I'm not displeased with this. Let's do, hang on. First of all, I have this other terminal up on my side here. Let me just make sure that this is going. Okay, I'm gonna need this machine back soon. Yeah, I'm gonna need this machine back soon. In fact, I kind of want this machine back now. Yeah, I'm gonna kill this run. We'll do the client crap later, maybe. Okay. Oh, this is up to date, right? Yeah, we're up to date here. Oh, wrong machine. Okay, now we're set. Okay. Laggy, man. Okay, I'm gonna do this, and then I'm gonna, while this does that, I'm gonna actually make sure I know the correct implementation of this. Yeah, so we have lots of this. Okay, this is good. Where was the warm up? Momentum warm up. So this is November 6th, 2024. Yeah. Why is this not? Is it this? Muon doesn't need learning rate warm up. Muon doesn't need it. Interesting. Plus moment. So wait. Steps equals. Okay. Value residual, embed shortcut, and then momentum warm-up is this little thing here. Value with residual with learnable lambda. Hmm. Over the first 500 steps, it says. See, the thing is that language modeling bros have such a more consistent task that they can do stuff like this. Hey, Jess, we're doing a couple like chill little research things based off of the Nano GPT speedrun. And then we'll see what we do from here. Results from last night are, I think, decent. We have it, I like to see. Can I show them real quick? I think we're gonna need to make some improvements to the to protein, honestly, because we're sort of hitting the wall with how many hypers we can tune. So here are the results. We do get soda. We get soda by quite a lot, but like the curves are overlapping in this weird way, right? So that is still a nice soda result. It implemented warm-up momentum from 0. Nice fucking job. Oh, Alok, welcome. Relu squared. These are like giant leaps here. Add the embedding to 64. That's just pure speed. Hmm. Zero init QK norm. Doing a few like chill things based on the Nano GPT speedrun first. Just see if we get any easy performance wins. And then I'm probably starting some heavier experiments or maybe modifications to protein. I'm trying to build stuff. Stupid thing. Okay. Yeah, but how do I address that, dude? Yeah, this is actually a very small thing, it seems. Learning rate is maxed. Huh. Did you publish? No, I really decided that there wasn't anything reasonable for me to write about the topic. Um, because the thing is, there really isn't any, like, interesting substance to write. And the only thing I'm gonna do is give ammunition to idiots that want an excuse to not think. Because, like, the TLDR is, I use some tools, I try not to over-rely on said tools. I keep trying to think myself, thank you very much. Um, that, like, there's not actual substance to the topic, frankly. See, but the thing is, like, I'm not switching models because I think one is, like, materially better than the other or anything. I literally just got sick of I got sick of feeding Anthropic money. That's literally it. It's not that deep. Oh, well, duh. Idiot. Hey, we'll try this. Apparently, I don't think Muon needs warm-up. We'll try a couple other small things, though. All this stuff here is, like, high likelihood throwaway, for reference. So basically everything past this point is super minor. Streams with Jim. Oh, the gym is in Maryland. I'm in Palo Alto for the summer. I did not say that these streams would be from the gym. And I missed one run this morning because I hurt my back deadlifting yesterday. It's getting better, but it needs a day to heal. Like, I could barely walk at all yesterday. Yeah, I've been running 10K. Well, Monday through Thursday I did. I also did one on Sunday. I'm gonna be running again this Sunday and then next week. I missed one run today because of back injury. I think I probably will do some lifting still. I think I should be good to do that depending on what I do later today. I can definitely at least bench. And then the streams are right here. Right? The streams have been every day. You know, the deadlift thing was dumb. It was literally just really, really shitty deadlift form because I was so tired from the run. Because that's like 4 days of running in a row on a very aggressive cut. No, 5 days in a row on a very aggressive cut was a little bit much. I'm gonna try this. I think that this is getting rejected anyways. If I don't see a big difference from this, we're just gonna reject all of this. I think we do potentially want these muon improvements. Yeah, see, it doesn't need this. Rescaled weight updates to have unit variance per parameter. Okay, that thing is dumb. We'll just do this. Bash. We've also ended up making some pretty sizable breakthroughs in the last few days. Research side has been going amazingly well. Okay, there we go. So 5 million step warm up. Wait. Okay, we might have something here. Can I get away with 0.2? I have to figure out what color means by not required because that is a 2-second breakout solve. Annealing with warm restarts. You still have the problem, don't you, Jess? It's just under 3 seconds. but it's still under 3 seconds. I imagine there's probably a bit of seed variance. I'm still going to post the screenshot in the Discord. Yeah, there's a lot of seed variance. I think there might be a thing with Muon's updates. I also wonder what if I just do this. Hmm. Different transformation. Wait, what? Helps on cycle length. Well, wait, you don't literally just do a cosine, Jess. It still decays. Yeah. I don't think there's a good answer to that particular thing, Jess. Hmm. I think this is what Aurora also handles. No, the new breakout solve was just me playing with some stuff, Finlay. We haven't tried the new algo on breakout at all. I'm kind of just fiddling with a few smaller questions at the moment. It's not super stable though, mind you, Finn. I'm playing with a few different things now. I want to set a new like stable speed run today. I'm gonna just try. I'm playing with a couple things here. That's still breakout, to be honest. And maybe we'll see. Just it's very, very difficult to figure out. I mean, honestly, in some ways, the language model people have stuff way easier. Um, like language modeling is a single, much more stable problem compared to what we have here. Yeah, so this should fail horribly because the learning rate is way too big, right? We have to divide by 8. Yeah, so this fails horribly. Okay, that's nice. We alive? Stupid internet, man. Think we're alive. Okay, this is stable. Okay, that's pretty stable at 80 mil. Get Moopy into the update, maybe. It's funny. That is kind of what I always say. Like, yeah, okay, if you can do way more, but most devs are doing negative work anyways. I want to see if this helps anything. I wouldn't be surprised. This might be worse wall clock, but we can optimize this. So the question is, if I keep same params, is this stable in fewer steps? Let's go down to like 60. This should not solve, right? Yeah, so like if I do... Yeah, so this is where it gets volatile because we're towards the end of the curve. Yeah, very volatile. What's this Aurora? Okay, so this is Muon, supposedly. Okay, so they have this small improvement. %6 overhead is not worth it, actually. Yeah, this 100x data efficiency thing is bullshit when they have this. This is actually the main graph here, if you look at it. What's this Normuon? This might shift stuff massively. Oh, interesting. Okay, I think this is better. Yeah, no, we can't increase the learning rate. This is good, though. All matrices. Go check this thing. I think Aurora. Just like miscellaneous little potential tweaks, Jess. This is a very nice little blog post. Hmm. Interesting. These are basically the same. Yeah, these are tiny little soda. Let me see this polar. Where's the polar thing? There was a polar bit here. I see. And then wasn't this in Nan is the speed run as well? Okay. Where do they have these MLPs though? Guess the number. There's nothing to learn there though, dude, right? I tried a version of that made a bit more sense with like a password type env. It's annoyingly like static though. So this is interesting. This seems very bad. Um, but I think we just solved this with the orthogonalization change that we just made. Too few obs. I mean, we have some M's convert. It's gonna be mazes Sokoban, 2048, and Inferno. Those are 4 good test Ms. Try this on Breakout as well. Possibly we'll try it on a couple other things. And then let me see what was the we're going to also, I think, do a little bit of this just so that we get slightly more transferable learning rates. We'll try this. Just a few small improvements today. And let me see what else I said was going to be important. Oops. So this. Okay, cool. If we do all of this, then we basically just have protein and then this one other little weird bug. That's fine. That's fucking hilarious. That's not how it works, my friend. Yeah, analyzing 400 million chess games should take, like, seconds, minutes. Okay, we're gonna let it do this, and we're gonna test it. And then we're gonna fuck with it. What's this rectangular beta? We're not adding hypers with this shit. If it adds hypers, we're gonna delete them, don't worry. I just basically want to see if this thing is roughly stable under same hypers first. And then we'll figure out from there. Yeah, Crit, I want, like, better tested EMs, though, for this. I want EMs where we have, like, more data, more experimental data. And we have a lot of experimental data on mazes. We've got a good amount of experimental data on Sokoban. We've got a ton on 2048. And based on Valo's stuff, we have quite a bit on Inferno. When you're getting back, I'm here for the summer, man. I don't spend the whole year in on the farm. I spend some time in Maryland. I spend some time in California. I spend some time in Florida. Wait, does Aurora add 2 hypers? Stupid thing. Think we're gonna comment this and try the polar real quick. think this is still going to be screwy. Yeah, I thought that as well. It's not actually Nor. It's neuron-wise normalized. So it's a really fucking stupid name. But whatever. Okay, that restores mostly. Perf. Nope. Did this take a bite out of perf? It did. A little bit. I don't ever want my search engine to give me a pop-up about AI mode. Fuck off, Google. Where's the paper? Never got Aurora to work at reasonable speeds. Yeah. So here's the thing, Valo. Aurora is aimed at non-square matrices. We have the embedding layer is non-square. That's not a huge deal. The big one is that we have the projections in Mingru. They're h to 3 times h. But, actually we shouldn't be trying to treat them as that shape anyways. They should be being treated as 3 separate orthogonal matrices. So I'm just trying to take little bits out that I'm pretty confident should work. It's mostly just the coefficients. Sure thing, Jess. If you feel like helping with that. I got sick of banning them because it shouldn't be my job to have to go ban people 10 times a day because Twitch can't moderate, like, the most obvious spam ever. There. Should be good. Like, why should I have to be distracted constantly because Twitch can't do basic spam filtering? Is that better? I think that is better. So now, if we do like 80 mil, we definitely solve, right? Cool. Okay, so this is an improvement. I think this is slower. Or this could just be the orthogonalization price that we've paid. I wonder if we can make it faster for square mats. One giant file. I see. What the fuck did it do? Why did it do this? Okay. That's fine. Few small optimizer improvements is fine. How fast do you think you can get it working? I mean, I think you could easily have some reasonable stuff in a day or two of work, at least against scripted policies for sure. Other paper? What paper is that? Give me the name. 19.5, 19.2, 19. Okay. It's the same. Fine. Yeah, I saw that. Okay, so polar is better here. Let's try muon polar 0. I just want to try this with a couple seeds. Because polar is supposed to just be consistently better. Okay. I think I'm happy with this as being a very small change that's likely correct. Random or inverted spectra. Okay, this doesn't that doesn't seem to matter. Is this anything? You were spot on, idiot AI. This was on X. Bots, man. See, but we don't want polars. No, we don't want to compromise the polar quality, I don't think. What's this? Yeah, but we don't care about this. Oh, I forgot to reply to Jess. Well, it depends how fast the scripted policies are, right? Like, you should be able to get 10 mil plus easily with a very small policy, and then it just depends on the optimal policy size for the problem. And we get Moopy and we'll be good. This is a completely reasonable thing to do. Like, that's a completely reasonable thing to do. That's funny. That's super funny. That's super funny. They have way too much money for sponsorships now, though. That's funny as hell. Uh, what do we got here? Hypershift. Ugh. Okay. No, we can't keep it global. What are the CUDA live ones? I don't have any, man. There really aren't that many people streaming like deep technical dev. Um, I can go over what I'm doing at the moment. So they're just like a variety of medium confidence, small like optimizer side tweaks that we can make. And obviously validating that type of stuff extensively is quite difficult, but there are a few of them that are almost certainly almost certainly good. So a few changes to how we're orthogonalizing our parameters in Muon. We currently have these projections that are H to 3H that we're treating as one matrix instead of three. That's bad. There's a slightly higher quality orthogonalization algorithm that we can integrate that's pretty much shown to always help, and it's almost free. What else? Oh yeah, we were messing with warm-up, but warm-up doesn't really seem to be necessary or help. We were messing with the Aurora corrections. We realized we don't need it as much as we thought. We did shift our learning rates, so I want to get MUP in. I'm not implementing all the papers. Like, that'd be way too much complexity, and most of it's not really necessary for this. I want to get us like a few conveniences. I'm going to try to get us like more stable, consistent learning rate parameter. I'm going to try to get us like slightly more stable orthogonalization in the optimizer and a few other small things. And I think collectively this will give us, a easy small boost to puffer. This is just something I haven't had time to do, And like many of these things were released relatively recently, and I just haven't had time to go through and apply them in a reasonable way. Hmm. We can check that, can't we? 861. It's codex. For research coding. I mean, my general take on the models at the moment is they've gotten better. They were if you were using them heavily a year ago, it's just because you're a terrible programmer. They've gotten better. They're still incredibly dumb. They make huge, huge, major errors. They will make a complete disaster of your code base if you just let them do whatever. But like they are useful tools, and I use them in a, I would like to say, more limited and controlled way compared to what you will see people doing. Oops, this needs to be rebuilt. Try this. Okay, well that's a complete disaster. That's bizarre, yeah. Yeah, you know what was really funny? I saw on X earlier today. Somebody implemented like a bit internet, man. I can't tell if that's the internet blipping or if it's restream. Yeah, I saw that Somebody like went to implement their own rendering library and just full vibe coded, and then they ended up ripping off Raylib so badly that it was identical API, like literally identical, and they even copied the color constant names of Ray White and stuff. So I'm sure they thought, wow, look, I just implemented a whole rendering library with the LLM, but literally just copied Raylib into TypeScript. Well, it is the worst thing to copy in the sense that it's already perfectly well built, and your shitty vibe coded version is just going to be way worse. Okay, let's try this. And then I think we can merge some of these things after. By 8. Okay, it's back up, I think. I think it is supposed to just be 0.1. Sweeping Zulra. Mystic in a magic short bow. 2.1 times. Heh. That's good. Okay. Okay, so we have this now. Okay, so it trains with bigger hidden policy. With the same learning rate. Okay, I can train decent enough with Okay, this seems to work as well. So we'll see. This is supposed to fail. We'll see if it does. Okay, cool. I can confirm we get much better. This is absolutely, by the way, watch me bumble through optimizer crap. Um, I have a vague understanding of what is going on here, enough to not be being like completely stupid, but there's still going to be quite a bit of stupid stuff here. I am pretty confident I can do this well enough to not make any major mistakes, as provided I ask a bunch of dumb questions and like sanity check things repeatedly. Okay. I think it is stable enough. Smart enough to. No, I'm smart enough to mostly avoid the LMBS and at least catch it downstream quickly most of the time. Mention dependent magnitude. Those are compatible. Okay, so I think we just have to make sure they stack them correctly. That's fucking hilarious. Does profile still work in 5? Um, the profile script, I think, should, unless I broke it yesterday. I might not have pushed everything because I was messing with that. There is no more, I think, is there a dash dash profile thing still? I forget. We do have a profile script that gives you all the Turk kernel timings and stuff. Okay, wait, raw muon ortho. Original was same scale as original. So did we end up the same shit? Original full matrix scaling and per slice mu p. Okay, so we basically end up at the original thing. We kind of get lucky that when we do the per slice version, um, we get we basically get the mu p roll. I see. We could make it count non-zero. Wait, is it square root of c? One of the square root of the input dim? No, wait. I think the original Moopy is correct. New All-Star season? That's fun. Oh yeah, I can show you one cool little thing. Hey Valo, maxed on leagues. Honestly, the only thing that was annoying is I had to do about 3 hours of agility. No, the agility relic is troll. Because the hunter relic solves um the hunter relic solves 99 hunter not terribly, and it solves basically the 50 mil fire making as well. Doesn't the decoder need this? I think the decoder needs this as well. Oh yeah, Valo, I think I actually got all of the optimal relic choices for my regions. I think I did it pretty well. And I'll be finishing it at rune tier. It's not worth my well, I'm not gonna put in the time to get dragon. But hey, I'll finish at rune, which is cool. I mean, that's just like an absurd amount of time grinding boring shit anyways. Oh, okay, cool. This looks like this actually helps. Yeah, so look, now we have the same learning rate. We solve with 1024. And we should solve if I go to 64 as well. Yeah, we solve at 64 pretty well. Cool. Does. Okay, it currently already does. Is it 18 mil? No, we're at 19. Good. Also, keep in mind, the original was 93 mil. Okay, we should be fine then. And we're probably fine here. Okay, so this is now good, I would say. I can at least, can I put this down to 90 mil or 85 mil? We can definitely keep it here, right? Try a few seeds. This is nice and consistent. Why are you not sweeping here? I'm doing quick checks, Valo. These are just quick checks. So all I've done is I've added two very high confidence things, right? So I've added there's a learning rate scale that should just basically bring everything up to the same scale regardless of hidden size. It's pretty much just equivalent to tuning by I think it's like 1 over square root or whatever of the hidden size. And then there is one additional thing that we have, which is oh yeah, the polar orthogonalization. That should just be like a slight numerical win. And then there was one thing that we were just orthogonalizing wrong. So that's basically not really a bug fix as much as it's like a better mathematical model. So we're orthogonalizing the correct thing. And then that also makes us immune to most of this stuff Aurora is trying to do anyways. I don't know. Do we need the Aurora correction for linear layers? H is greater than obs dim. Well, that seems important. And then the one other thing I wanted to try was the scheduler. And then we'll basically take all this crap, check it on a couple problems that are actually tough, and we'll see if they work. Oh wait, this is actually nice. This is the thing that actually Jess was asking for. Stopping time steps in advance, yeah. Okay. That would actually be a major upgrade. Lots of little things together today. Looks nice. Yeah, this is still good and stable. Oh, wait, are we at 17 mil? Was that a thing? No, that's eval. Okay, we're good. And we just do policy hidden size. Okay, this works. Where are my bookmarks? Okay, this is the schedule free guy. Also, what happens if I just do there we go, that's nice. Yeah, we're stable at 80 mil now. Mostly, let's say. Seed 5. Yeah, this is stable at 80 mil. We just shaved some steps off the optimizer. Very nice. And then this schedule 3 thing is going to be the next thing we look at. This would be really good. Like, this shitty Disk schedule is such a pain in the ass. Good, we get rid of all this crap. I'm gonna use the restroom real quick. Actually, this is a good time for me to take a short break. In order to grab my vitamins and stuff and get myself coffee. Let me just make sure that this is set up. Oh yeah, this is a great time to remind folks, if you're new around here, I stream all my research right here. If you want to help me out for absolutely free, just start Puffer on GitHub. Like, it's that easy. It really, really helps. Because we do a lot of professional work as well. And when this number goes up, people message me, and I don't have to spend my time advertising. Meaning I get to spend my time here doing live R&D. You can also join Discord if you want to get involved with this development effort. A lot of it is much easier than you'd expect. Like, all these environments, super useful for research, mostly by contributors. You can also follow me on X for more RL content, including all my educational stuff. Let me make sure that this still works. We're going to obviously go through all this stuff today. Wait, did it get rid of the right thing? Yes, it did. We're good. So then that is basically slight difference to learning rate scaling, slight difference to rather the update scaling for MUPI. So now we have much more consistent learning rates across model sizes. Slightly better orthogonalization method. and then much, much more correct way that we are applying orthogonalization with the way that our encoder layers work, because our encoders have H to 3 times H dim, but it's really 3 separate map moles that we're just sticking together for the efficiency. So this will be much better. No, I'm not leaving early. I'm just gonna go grab myself a coffee and get my vitamins and take a few minutes. And, stream's been doing decently well. We typically are somewhere between 10 and 20 people across YouTube and Twitch. I don't know about X, actually, because X never shows the exact count. Make sure we didn't break it. And then we'll do schedule. Well, actually, Jess, the next thing we're going to try is schedule free, which would fix the cosine annealing problem. Be very cool. So that would give you the same learning curve. And then if you just run it longer, it should just be better. And of course, we deleted this argument. Okay, we'll do this next. Be right back, guys. All right, cool. Hey, this will what? What is all these people all of a sudden? Okay, cool. Hey, folks, welcome. Okay, next thing we're gonna do. Oh, for fuck's sake. No damn coin people. Out. Get out. Serious research. Actual, real academic research happening. Jesus Christ. This happens like every few months. Stop. Stop using my name for coins. Stop. There are other people you're gonna get with this. I'm not one of them. Alright? We charge 6 figures plus for our contracts. You're not gonna get me interested in whatever shilling coin thing. Back to research. All right, so this is what's actually happening in this stream. So, at the moment, we have just integrated a few tweaks from Keller's. If you've seen this thing, this is an awesome piece of research. Now, a lot of the modifications towards the end here have been like very specific minor things, but we got a few of the muon improvements from here. We did this, but then we integrated MuP, which actually, funny enough, gets you very close back to where you started. But we did make one important change, so now you pretty much should not have to retune learning rate just because of changing model size. This should also make it easier for protein to learn. We don't have more MUP or anything else. We don't need that. And the next thing, so with this was pretty good on its own. We also integrated, this is a really good blog post. I highly recommend this. This is the Aurora optimizer. It finds a bug in muon and patches it, essentially. I figured out that the thing that this thing is trying to patch algorithmically, it actually only applies to our embedding layer. So we applied this there, but the rest of our layers, they go from H to 3H, which would be affected by the muon bug. But actually, our layers are 3 matrix projections. It's kind of like the QKV from Transformer, but for a totally different purpose. We can just split those and do the orthogonalization separate, and then we don't have to deal with it. So we only have this for the embedding layer, which is super nice. And then a couple other small things, and now we've got some pretty consistent results. Only 80 million steps, 4 seconds for breakouts, quite nice. And then the next thing we're going to do here, so Jess, this is the thing that you've been requesting, and actually this has been a pain in the ass for a long time. So the idea is that having to have a learning rate scheduler makes it very hard to scale your experiments, because you're essentially messing your learning rate will actually change. Let's say that you run a 10 bill step run, okay? The learning rate that you use at, say, 4 million time steps in that run will not be the same as if you do the same experiment for 100 billion because of the scheduler. And that screws up hyperparameter transfer very badly. So we're going to try this for that. I'm going to start reading this at the same time that I just give it here. Oh, actually, remove. Well, here. Okay, next thing. View. Going to try. Great Schedule free. Boom. There we go. And now we actually read. There should be no YOLO training runs. All right, this guy rocks. Yo, okay, this guy rocks. Does Twitch have mod? Twitch doesn't have fucking mod. Yeah, dropping pump.fun links in my chat is insta-ban. And all your alts as well. Okay. Yeah, and if any of my real viewers were curious, I'm not affiliated with any of this stuff. They're trying to steal your money. So... Where's the actual paper gone? Inner momentum into schedule free fixes large batch training divergence. Ooh. That actually is interesting. I don't know about this problem. Replaces decay with iterative averaging. Okay, warm-up still usually is. But then Muon is supposed to not need this. I see. Okay, we need the large batch changes as well. Wait, well, eval checkpoint uses X. Rollout / train uses Y. Wait, explain. I need this API difference. Wait. Actually, I can just click this, can't I? So, takes the current loss as a scalar instead of a closure. Huh? You don't need the closure. Okay, normally there's one parameter vector. You compute gradients, optimizer updates, and you evaluate and checkpoint. Schedule free has raw optimizer iterate, averaged iterate, Fourier iterate, weight used to compute the next gradient. So the next gradient is computed at yt not xt. Evaluation checkpoint final mode should use x. I see. We can just save the eval weights checkpoint. We'll try this first, and then we'll see what the hell's. We'll see if this makes any sense. This has to be able to at least match on breakout for me to want to be able to like mess with this. So this adds one hyperparameter, I believe. But I think that's worth it for deleting cosine annealing. And all our other annealing things have not really mattered that much. It's a little irritating, though. All these LLM guys are basically training on the same exact task, right? So they all get to just swap hyperparameters with each other, whereas in our case, we have a bunch of different problems, and nobody's doing the same problem. Okay. I think this is relatively promising. It's got an endorsement from Lucas as well. I mean, if all of these work today, then this is basically let's say that we don't get the learning rate free stuff, all right? But let's say that we get the decay schedule free. So we have a learning rate that we tune, but we don't have to have a schedule on it. Um, that would mean way better transfer of hypers to longer runs. And then from the other stuff that we did earlier today, or just before this, we also should get substantially better hyperparameter or learning rate scaling to larger networks. If you change the model size, the hyper should stay way, way, way more the same. And you should also just get a nice stability boost overall from the orthogonalization changes. So, several small things that together would be a quite meaningful improvement. Now, all this stuff is going to add a little bit of overhead to the algorithm, but we will iterate on our kernels and stuff to get around that. So yeah, like, look, blah, 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 blah. Too much code, right? Way, way, way too much code. Of Puffer 6? No. We'll see what's in Puffer 6. I think that I want to have, like, very, very stable... If by Puffer 5 we have very stable everything, and pretty much the remaining problems are, like, clean and well-defined, then Puffer 6 will aim to solve the remaining ones. So I think Puffer 6 is like, RL is stable, mature field that works, in my mind. In case it wasn't obvious, this is way, way, way too much codex usage. The only reason I'm doing this is to quickly explore all these things to see if they even work. And then if they do work, like, this is all tech debt that this is not going into the update, right? Like, this is going to be manually cleaned up dramatically. Yeah, better get your contracts in by Puffer 7. By Puffer 7, we charge 7 figures. Now, realistically, by Puffer 7, we'll probably be looking for some very large applications that we can just take on internally in Puffer. I think we'll actually even, like, Puffer 5 will even just let the Python still be in it. Probably Puffer 6 will be no Python. Yeah, I think that's probably the case, Jess. Like, Puffer... So if Puffer... I think Puffer 5 will be a quick update. Internet. Are we alive? Okay, we're alive. Yeah, so Puffer 5 is gonna... So Puffer 4 was a very long update. Puffer 5 is gonna be a very short update. Puffer 6 will probably be somewhere in the middle. And then 7 will likely be, like, an applied problem. Maybe even 6 will be applied, who knows? Yeah, we don't actually need the, learning rate and schedule free. Yeah, we just need the schedule free part. We don't really need the learning rate free part. Cutting one hyperparameter is not that valuable to us. Well, I said that there wasn't like any obvious simple solution to it. Like it's this guy's whole research. I honestly forgot that this even existed, and last time I tried it, it didn't work very well. But apparently, I'm a little bit late on this because apparently this has been out for like a year plus and been kind of good. Like the previous version of this. Heh, that's cool. I know those guys. Just send a quick message. Cool. All right, nothing's worth it here now. Let's focus on dev for the next little bit. Close, close. The paper, though. Ah, here you go. This is nice. Okay. Ooh, Tim's got Boxabon at 10 at a 20 mil SPS. Very nice. Might have to tune their new params. Schedule free beta. Schedule free R. What was this beta that they gave? Beta 0.8 to 0.95, 0965. Could just be the parameters, could be the implementation, could be many things. Possibly this has to be much higher for the number of updates we do. Nope. What's the schedule free R? Oh, does this just need to be tuned? No, there's no value that's good. Maybe the learning rate needs to be retuned. No. Huh? Didn't need massive, massive learning right now or something? No. So what gives? I'm gonna have weight decay anyways. It needs to warm up, I guess. Maybe it's this. Yeah. Hmm. If we could get this to work, it would be very, very nice. We don't care about weight decay. Uh, I want to see if we can match cosine annealing with this thing. It'd be very useful if we could. Do we have more on this paper on Twitter? Oops. This is from 2 days ago. Nah, there's nothing on this. Maybe some of his earlier stuff. This is for weight decay. We don't care about this. Prioritized. What? Is that not just from the Dota paper? Is that a different thing, Jess? Oh. Wait, but Alpha Star has the whole league's bullshit. Yeah, this is nice. Adam C. I'm just looking for this guy's earlier stuff on schedule free if he's put anything. Weighted sampling of historical opponent. Alright. That could be reasonable. I am hoping that we get some simple thing based on historical self-play to work. Because, like, league sampling gets to be a pain in the ass. Yeah, let's see if this warm-up was the problem. Well, he'll try it, Jess. I mean, I'm actively discussing like the self-play experiments with him, because it's gonna be a major. We alive? Stupid internet keeps blipping. I hope it's not cutting the VOD literally every time on YouTube. Did it for me on Twitch. Lovely. Screen. Yeah, so this is just stupid long warm-up because LM is dumb, right? Oh, duh. What am I doing today? This is... Oh, hang on. This actually works. Hang on, let me finish this thought real quick. Ooh, okay. I'll explain in 1 second. Let me finish this tuning real quick. Okay, so what I'm doing at the moment is a bunch of miscellaneous optimizer, training, whatever improvements. These are mostly like small algorithmic tweaks that have been developed fairly recently. And I'm kind of just aggregating the ones that are the highest likelihood of improving things, testing as best as I can, only taking stuff from from good sources, not really doing anything that's like maybe works but not really. So far, we have made one clear mathematical fix to our orthogonalization inside muon. We've made one clear improvement to our orthogonalization numerical method, our algorithm for that in muon. Um, we have made one small tweak that allows us to have much more consistent learning rate across model sizes based on MuP. We added one slightly more speculative thing that changes the weighting of encoder updates a little bit. And now we are working on this schedule-free algorithm to see if we can replace cosine annealing, which would give us much more consistent performance from shorter to longer runs with the same hyperparameters. See if learning rate changed. Nope, not bigger. Just checking if our optimal like learning rate changed because of this method or something. Nope. Bigger and smaller are both worse. We'll trust our original learning rate. Some other parameters. We got schedule-free beta. Okay, that's worse. That's also worse. There's quite a gap here. Oh 0.8 annealed to 0.965. Wait, you still are annealing the fucking beta value, man. How can you possibly say that schedule free if you're scheduling your own beta value? Isn't that kind of, hang on. That seems very odd. What's the point if you're still scheduling the thing? Yeah, he has a fucking schedule in the schedule free. To lower it a little bit? Maybe the relearning rate just shifted a little bit? No, didn't. Oh, it's very unstable is the thing here. I wouldn't be surprised if I do 100 if it solves. Doesn't even solve in 100 though. And that's quite bad. Unless this is now like way bigger because try this real quick. Oh, it'd be great if this works. How much time am I gonna spend on this? Half hour more maybe? Or we conclude this is just like not as advertised. Okay, sure. Try that, but I doubt this. I highly, highly doubt this does anything. It's probably something like this. I'm basically just trying, just to make sure, like, the hypers didn't shift. Nope. Wait. First. I'm basically not going to put the effort into fully doing this stuff until I have some reasonable evidence, because I mean, this would be a big nice to have. So the thing that this solves for us, for our longer experiments, it's really irritating that we tune parameters, say, to like 500 million steps, and then they don't work when we run for 10 billion steps because the cosine annealing totally messes with the learning rate in a different way. Heh. Fucking assholes, I swear. And then they block you, so you actually can't reply to tell it to say that it's a scam. Is the funny part with that. Yeah, this doesn't work because this shit takes for fucking ever. They need to expedite this crap if they want to be changing shit. Uh, this keeps kind of fine, I guess. I mean, we'll try. I guess, you know what I'm down to do? I'm down to just, like, throw crap out wall for a bit. And if it doesn't work, we'll just remove schedule free. And we will go back to our nice thing from before. Let's also go to our default learning rate. Dramatically worse than before. Shit, did this like massively increase the optimal learning rate? Yeah. Hang on, let me see if it's 1. No? Okay, is it somewhere in between? Still don't think this is enough. 4. That doesn't work. And actually, it's not. It's supposed to be 0.1. I don't think that's atom oriented. You see? Because there's an ablation on this, isn't there? Yeah, this varies pretty massively, doesn't it? 1 over L1. Eh, hard to say. Mm, I guess it's possible that for muon, hmm. Yeah, okay, this is screwy. Do they have the graph that you would actually want in this paper, which is learning over more steps? Again, we're just throwing shit at this. This probably, if this doesn't work, this is all getting cut anyways. What? Setting R equals 0, maybe? Okay, here, we'll have a couple things to try. Oops. For context, this has become less of an educated guess now, and more of a, I don't fucking know, throw shit at it, see if it works. I would not be surprised at this point if this is, like, overfit to LLMs. We will see. If this does work, it will be very, very nice. We don't absolutely need it, but it would be very nice. I mean, what is this? Why is it like this, right? Other? Okay. Biased calc would do it. See, this is the type of thing I would catch if I were paying attention. This should learn something now, right? If it learns nothing, it's a bug. If it learns, like, okay-ish, Maybe it's just not super great, you know? Because I don't believe this just doesn't learn. Mm. Did I rerun the build correctly? Nope, not that. So, I mean, the thing I could only think of is that this is just not made for Muon. Nope. Wait, this is learning rate free. Okay. Schedule free learning. Ah, okay, wait, we didn't need poly. Okay, hang on. Yeah, we don't want this. Not the whole time, Jess. Last 10 minutes. Okay, so this is just supposed to be the schedule free. And that's supposed to be for long runs. That doesn't help. We can try the warm up here to a bigger LR, but I don't think this is good. This is not good, see. X is the model to evaluate. Okay. Okay. So it did stupid. Cool. We'll try a few more things because of everything I've messed up here. It's a very odd change, honestly. It's not like just swapping in cosine annealing. Okay. That's way worse. Lovely. Unless we shifted the optimizer. So that explodes. Wait, but then 2 does... Is this just noise? Oh, it's fucking noise, isn't it? If we assume that Muon doesn't need the warm-up. Ah, okay. Now we're getting somewhere. If we assume Muon doesn't need the warm-up. So it doesn't work without warming up, C. Thing. It does... Hmm. Isn't it supposed to just get better now if I do it like this? Well, no, it doesn't. It's in dev. It's quite messy. It's been in development just for the last like week or so. It's going to be a quite short update, but I will have something stable, hopefully, in a couple hours. I'm mostly just deciding what we're going to do with this schedule free stuff, and if there's any reasonable form of this. Well, that's fucking dumb. Schedule free does not work so far. It's close-ish, but it does not work. Wait. Huh? Yeah, it messes up if you don't enable the beta. So this will break it anyways. Still doesn't work. I mean, it's kind of close. I mean, this feels worse to me. This feels much worse. We had it very consistent without this, right? Like, just to kind of show you how fiddly this is. With cosine annealing. See how much better this is? I'm gonna give this until 3 p.m. and then we're gonna drop this as too fiddly. Unfortunately. And then if anybody else wants to do this as a project, they can feel free. We also shouldn't need 0.95. What's the project? This is schedule free. This is nice because in theory, this should at least, this should help for very long experiments. Hang on, I think I have the... I mean, I would categorize this one as quite advanced. Um, nah, it's still not good. Oh, for fuck's sake. Stupid Vim, man. Fuck. Not even Vim, it's like something is just fucking up my terminal and deleting the top of files when I open it. It's the most obnoxious shit. I didn't catch it that time, so I just saved the file. Fuck. Okay, so this is the thing. Okay, so let's do this one. Like 0.8 even. Okay, so we have this. This is close. No, this is actually close now. Long weekend, get some R&R, go for some runs, and we'll see from there. I honestly wouldn't be surprised if this shit just doesn't fucking work. Um, I mean, this is the problem with language modeling research. They literally have one problem. It's the same problem. It's super stable. It barely changes based on your data. Like, compared to RL, they've got all the stability in the world. This doesn't. I mean, the schedulers aren't going to help in the sense that, like, we'll still have the stupid mismatch. Yep, this makes fundamentally zero fucking sense for RL. Um, that makes absolutely zero fucking sense for RL. So this thing's got brain damage because I guess it's supposed to like solve some like pretty hard math theorems or something. But this is pretty fucking stupid. So I've played with this thing for 3 hours. This thing feels awful, horribly unstable. I'm done messing with this for now. If anybody else wants to mess with this, by all means. I don't think this approach actually makes sense because it's requiring you normally to run inference with a different set of weights from training. And in RL, that means you just don't see the portions of the env that you should. Like, you're not allowed to have a perf gap between your weights. That's not a thing that makes sense in RL. So Try first one. Try that real quick. And yeah, this is dumb. Wait, this does not remove. What the hell is it doing? Okay, I think it broke itself. Unless did I hit a key? Did I hit a key? The fuck? The fuck? What on earth? What in the actual fuck? That is a perfect summary of today. Uh-huh. Yeah, I think we're just not gonna deal with this, thank you. I actually don't want to keep this because I think it's like completely fucked itself, so let's just Yeah, we'll get ourselves a minimal diff. It will work soon. If anybody wants to try it, I'm not spending any more time on this. This does not feel directionally correct. I generally do not spend my time like trying to force a thing that feels super brittle and janky to work. That's not something I want to introduce into Puffer. If anybody gets a version of schedule free working that's actually like stable, consistent, works across seeds, you run it for more time steps and it just kind of just does a little better, but does keeps the same curves in the early part, like that's all good. This is a nice post. It's actually a very nice post. Cool. That's a very nice post. May the solver be applied to NetHack? You'd need state sets. So NetHack, you'd have to edit the source code quite a bit. It seems like the approach should help, though. We still have to run quite a bunch of experiments on it. Knew about the problem, trying it a few hours. Not really, and this is why I typically don't pull like random shit off of Twitter because most of the time you go and try it and it doesn't fucking work. Um, Keller's stuff has been quite consistently good, I would say. But like Yeah, the LLM people are just kind of rediscovering what happens when you have one problem and you try to do general work on one problem. I guess the exception is, well, it should be the optimizer work, but I think that the schedulers touch too many other things, not just the optimizer. Okay, give it all this crap. Basically, what I'm going to do is I'm going to get this thing down to a very minimal diff, and then PR, and then we're like clean it up. But yeah, like look at all these parameters we're getting rid of. Bunch of garbage. We will also be able to get rid of we will be able to get rid of the beta 2 param. That one is dead. And I believe there is also an epsilon parameter that we can remove. Oh yeah, what's the current decay in Nano GPT? Interesting. Definitely there's other stuff we could do. Like I probably shouldn't have spent so long on this, except I really wanted to have the better long experiment transfer. There's all sorts of other stuff I could be doing. Where was the last like big improvement made actually? LR decay to zero point 0.1 instead of 0. That's nice. What are we working on now? Cleaning up the PR. It contains several things. It contains orthogonalization, in better numerical orthogonalization method, more correct application of orthogonalization for min group layers. It contains better scaling for the encoder layers. And then it also contains this mu-p-like update that should make the learning rate much more stable over a range of model sizes. MuP was already almost integrated. We just needed a couple very small tweaks. This also should not change. I think this should not change the learning rates or the parameters required. We will see, but I think we should be fine. It just makes it easier to tune. It just makes it easier to tune because the learning rate's preserved. It's just a scaling factor. Okay, this still seems to work. Nice and stable. If I do this. That hurts tremendously, it seems. Hmm. So yeah, this one does not actually just transfer. Yep. This one's confirmed bad. Is it beta? Yeah, momentum. What's the problem spec? Right now, it's just a lot of very small improvements that add up nicely for Puffer. Nice, it replaced it in all the config files for me without me having to ask. We're gonna have to do, we're gonna have to clean this up to commit it, but it'd be a pretty minimal diff. Ugh. That's better. We might need, 85 mil. I think we'll leave it at 90 mil. We can retune though nicely. We can probably retune this well. I do kind of wonder what happens if we use params for mazes. What do we have for this? Let's see. Why don't we go grab? No, why don't we just go grab real quick? Grab this parameter. This param seems fun to me. Fuck. Yo, let me copy this parameter, yeah? There we go. Delete everything down to sweep. Oh, and then did we did sweep this, right? Yeah, we did sweep this. Cool. Jeez. Taking a while. Okay. That's not bad. We'll just leave this here. I'll be right back. Let me use the restroom real quick. Okay. So we'll see how this goes. The hope is that this is at least on par with perf from before, hopefully a little better. It's a nice configuration. Whole bunch of steps it runs. Decent little net. Okay. Anything else we can pull in from Keller? I don't think there's anything super great otherwise in here. Tuned learning rate. So Muon is the first really big improvement here. Not really. The Nano GPT baseline's pretty good. What's this ReLU squared? He batches all these three together. Oh, it's just the same loss, but it's faster to calculate, I see. Where'd it go? Where'd it go? It's funny, upgrade Torch. That's like a nice endorsement of Torch, I suppose. Port the whole thing to CUDA down to 1 minute. Untied embedding in head. I think that's basically the last big thing. Okay, so this was the flex attention thing. Big flex attention thing. Cool. Where is it? UNet. .404. Where's the UNet? What's this? God damn it, Geeks for Geeks. Oh. Well, that's not going to be relevant now, is it? Float 16 activations. Yeah, this is the last big one, honestly. So, value residual with learnable lambda, embed shortcut, momentum warm up, and tang logic clipping. It's mostly this. Value residual learning. This is actually very close to a highway connection. Yeah, I don't know, Jess. It's a specific architecture, not super useful to us. Okay, so there might be something we can do with a residual structure of some type. I think that's the last, like, major potential even thing in here, though. Um, yeah, most of it's just from padding the embeddings. That's funny. I had removed it for no good reason. That's funny. I met him in SF, Jess. He seemed cool. Power of two. Yeah, I was just going. All right, we're at 6K, 5K. Hopefully that run does all right. If it does way worse, I'm going to get concerned. But if it's within ballpark, I hope it's reasonable. Okay, so I think this is a nice little set of changes. I mean, the only other thing that we even have to do in Puffer 4 on that side is this one PR. Let me see, I think I asked him as well. Argmax without STD-based sampling. Let me see. It always takes the argmax, which gets stuck at the boundaries. Hang on. Let me look at this. Okay, I have argmax of the scores. And then what's this one? It's in Pareto Genetics, so this is in always takes the argmax over scores. So presumably, no, he still has argmax in here. His comments don't make sense to me, but let me see. It loves boundaries, picks the argmax. This is definitely some Claude because it's just deleting all my fucking comments. Yeah. So what? He replaced our kernel with a worse one. Wait. Oh no, he put it back? Wait. He basically deletes one of our pruning heuristics. This is also not understanding our thing. I'm gonna have to just go run this thing on like breakout in a couple of M's. Because some of these things seem very weird to me. Yeah, so we also intentionally didn't do this because it's super sketchy with the way that RL outputs are. The sampling thing. I don't actually remember what the hell that is. Wait, what? Yeah. But why? I'm so confused. And while was there 6K? Was there when you had 2? Oh, welcome. I just keep going on the research agenda here, huh? I'm so confused by what this PR is, though. I mean, I'm gonna just have to try this. Like, he says this is better. I have no idea what the fuck. I'll probably have to spend a few days next week on this. See, I don't understand why he thinks this is a bad thing. That shouldn't result in converging to boundaries. That's not how that should work. So this adds quite a bit of complexity, actually, because it looks like this is about a same size PR, but he's deleted all of the comments. More likely Claude has. We will try this, though. Yeah, 12K. If this does better. Puffer profitable? Yes. Well, rather the company is. The library is free. I'm afraid this is gonna end up a little worse. We'll see. What is the? What's this trade-off look like? Actually, this curve is kind of nice, isn't it? Like, if I put this in linear, yeah, this is kind of nice, right? You spend more compute, it does better. Actually, look at this. So this actually looks like, okay, we can put this being worse at low scale down to bad tuning, but it looks like this is actually scaling better with compute than before. Yeah, we do RL projects for companies, basically. We build high performance sims, we integrate stuff with Puffer. Most people just cloning the project don't have a decade of RL experience, as well as the experience of having built the library itself. I actually think that this is possibly, yeah, when you look at it this way, this is quite solid. Now the question is, did I mess it up in the latest commit? We're seeing the 16K on there occasionally. So I suppose we will see. One moment, I'll be right back. All right. Is this Windows CMD? Well, I'm SSH'd into Linux boxes. This is an old machine that happened to still have Windows on it. Okay, so I managed to lose a little bit of perf. I will have to rerun the sweep on this. I'm just thinking what I want to do. Let's try. Go to here. It's still better than previous. Is it better than previous soda? Hang on, how much perf did we lose? No, it isn't now. Shit. There could still be some variability in there. Hmm. So we'll just minimize this diff. All of my stuff is on policy. We found last summer that off policy just straight doesn't work. So this is Pufferlib's high perf custom algorithm. It's on policy, or at least it's on policy as PPO normally is. What I did today was I did some nice optimizer improvements. Just some like very small but important math fixes on the way that we do orthogonalization, how we apply it, a few other small things like that. We're going to rerun some hyperparameter sweeps based on this. We've also got protein to mess with, which is the sweep algorithm itself. So I think I'm just going to set 2 boxes up of worth of sweeps right now. Okay, we can get that. Q-learning is just... So the problem with off-policy methods is that they don't scale nicely with compute. It's not like, oh, you can do as well as on policy and then spend a little bit more compute and do better. It's like you spend a massive amount of compute to do as well as on policy, if you even can, and then you spend a massive amount of additional compute to try to do a little better because you didn't want to run your simulator for a few more steps. So Jess, as for what improvements, I have no idea. I have a big PR. I don't understand what the hell it is. It's by somebody who is good. And he says that it is much better than protein on the stuff he has tested. So I'm going to probably overnight, I'm going to run a baseline with the current breakout. And then I'm also going to run 2048 again. And then after that, we will see. Yeah, I know Jonah's PR. Jonah's PR is kernels and infrastructure. Kernels and infrastructure are part of 5.0, but like the first 2 weeks are not about that. The first 2 weeks are about like getting all of the algorithmic changes in. That'll be it. This can be cleaned up, but this is actually not bad. Yes, we have a few people in the community that are interested in doing stuff around that. Yeah, like Jess here. Okay, so this runs. Would be good. Cool. Okay. This is nice. Oh, actually. Yeah. Should be able to sweep this. Twitch chat via live stream. Yeah. Make sure this is still good. Looks fine. Okay, get pull. Oops. Been live 6 hours, it looks like. Just shy, maybe. Upper end of the comp. Depends whether people in Puffer want to release that while the comp is live. Maybe if you ask Jess nicely. Let's also just grab the parameters if we didn't already. I think we did get them already though. Yeah, no, because we already did just commit up all the params. We should be good. Yeah, no, Twitch has the lowest delay. YouTube has not bots. And X has the biggest audience, I guess. Okay, so that's now 2 sweeps going. Okay, we have all these runs going nicely. We can see that here. We can see we have this going. 2 runs, really? Hmm. Seems a little bit odd to me. I want to make sure this is actually running correctly. Okay. Um, that is quite nice. Now we have 6 runs, so this is actually working. Good. This is working. So today we integrated a few smaller changes. Things should generally be fine. If I wake up in the morning to a much better breakout sweep, that would be pretty cool. I think these are going to be pretty small changes, though. Integration of Polar Express, angular connection. It's like four small algorithmic changes. This one's basically guaranteed good. This one's guaranteed good. This one's guaranteed good. The only one that's a little questionable is the Aurora one, but I think that should be fine as well. It may or may not be required. But I think the other ones are pretty solid. Hopefully we recover the original. I really, really do like this graph though. Like the more that I look at this graph, it doesn't look very good on log scale. But when you put this on linear scale, this is a whole nother story, right? Like we care about asymptotic improvements in the algorithm. Look at this. Look how far this goes on the log scale. And then look how much steeper this is here. So it seems like this scales quite a bit better with compute. And I guess for this end of that kind of makes sense because This should be a lot better at the end games. This is the state set algorithm. So, I mean, we'll have to see from here how this does, but I think it could be quite good. I think it could be quite good. It is for today. I think I'm going to end a little early for the long weekend. May or may not stream on Monday. I think I said I would, but I forgot it's a holiday weekend. Um, I probably will. We'll see. We've also made very, very good time on these changes. Like pretty much the only thing that we have to do left. So we have to make sure that these changes are fine. We got to run some more sweeps on 2048. Um, we have to run some sweeps on set up some sweeps on the other 3 test M's. Really 2 test M's, so not that hard at all. And then what else? I think that's it on the algo side, really. I think that's pretty much it. The only question is if we can have some nice improvements to protein or not. Even if we can't, though, how many hypers do we have? We did add some more hypers. 1, 2, 3. Yeah, it adds 4 hypers. Quite a bit. Yeah, it's quite a bit. Well, we shall see. How do I aggregate into set over the episode? Not 16-bit encodes. You should just look at the current 5.0 repo, Pepper. It's like a combination of keeping top K highest advantage states, saving every 16 states into this buffer, reweighting the advantages every time you get new information updates. It's not a lot of code, but it's a pretty complicated thing. I don't know what that is, Pepper. Yeah, this should be quite good. This gap is a little concerning here. I think we just need to make some improvements to protein, though. Possibly we need to do some analysis. Again, just I don't have anything in mind on the improvements. I have a big PR that I don't understand from somebody very experienced in optimization. And I'm going to basically try it, and if it works, I'll try to understand what the hell it is. We definitely need to understand stable ranges for hypers better. I bet you like that if we just do I bet you if I just do something basic like this, the learning rate optimum is way tighter, right? Already? Like right in there versus let's say. Yeah, see it widens with the bigger hidden size. Interesting. Low day. I believe I'm not sweeping this one. Yeah, so that's fine. This is a standard breakout sweep. And then this should be a state set based, yeah, state set based 2048 sweep. Good. Okay, I think that that's basically all I need to do. Let me make sure this is still going. And then this is still going. Okay, cool. So thank you folks for tuning in. I'm going to call it just about here. If you'd like to support my work for absolutely free and help me to be spending more of my time streaming rather than on annoying administrative stuff, you can help get the word out just by starring Puffer on GitHub. If you want to get involved with development or join the community, Discord's right here. And other than that, you can follow me on X for all of my other RL content, including educational stuff. For instance, the blog post about this latest block of research, that'll be there on X as well.